welcome to week 3. This week is all about exponential functions. This is really a simple concept. It's basically what we've been doing all year. We're going to be graphing these things. Now, your assignment is, I believe there's 15 problems or 16 problems that are all graphing exponential functions. Unfortunately, the only way I could get an assignment was to provide something where you can draw the graphs. You're going to have to print them out and take a picture. It's going to be the easiest and best way. If you don't have the ability to do that, I'm actually meeting with some of the math teachers a little bit later. We're going to talk about if there's a good graphing tool for the Chromebook so that you can submit them that way. So that's if I find a tool that would be easy for you guys to use, then I will go ahead and make sure that you have that. I'll put it in the agenda as well as shoot you a little note with a link to the tool. But let's jump right in. Exponential functions are always written f of x equals a base b raised to the x power. This is the parent function. And we talked about this at the very beginning of the year. Now, this number b is going to change. Now, that does not mean that it is a translation, okay? It's a completely different function. And we're going to talk about the transformations. All of the transformations are going to be exactly the same. If you put a number in front of the b and multiply it, that's going to be a stretch or a compression depending on how big it is. If there's a negative in front of it, it's going to reflect it and turn it upside down. If you add or subtract a number to the x and the exponent, that's going to move it to the left or to the right. If you add or subtract to the bottom or to the outside, that's going to move it up or down. Okay, so it's the same translations that we've talked about with the quadratic, with the cubic, with the rational. All of those things are going to be exactly the same. It's just going to be on an exponential function. Now, there is a couple of differences that you need to make sure you understand. Okay, number one, b has to be greater than 0, which is the mathematical way of saying b can't be negative. Because think about it. If b was negative, what's anything squared? Well, it's that thing times that thing. So let's say we have negative 2 squared. Negative 2 times negative 2 is positive 4. But then negative 2 cubed would be negative 8. So that graph would be flipping between the negative and the positive. There's no way that you can actually graph that. Okay, so b has to be a positive number. Okay, b can also not equal 1. Okay, just think about it. 1 to any power. That's 1 times 1 times 1 times 1 times 1, still 1. So that would be a constant function, not an exponential function. Okay, so there are two things that b cannot be. b cannot be negative, b cannot be 1 in order for it to be an exponential function, in order for it to work. B can be fractions. We looked at that last week. That just means it's a decay function. Which means it's the graph just kind of goes backwards, which we'll talk about a little bit here in just a second. Okay, so the transformations are exactly the same. Like I said earlier, f of x equals a times b of x plus h. We'll do this plus k. This should look familiar. I'm sorry I don't have all the rainbow colors of Expo markers like I do in my classroom at home. But this is exactly what we've done with the quadratic, with the cubic, with all that kind of stuff. When I multiply a number right up here, that means that I am stretching it if it's greater than 1, or compressing it if it's a fraction or less than 1, in between 0 and 1. The h right here, if I add or subtract a number, that means I'm moving the graph either to the left or to the right. It's a horizontal translation. And then k is a vertical translation, meaning it's moving it up or down. So if there's a number added or subtracted outside or not in the exponent, that's when we move the graph up or down. Okay, your homework assignment for this week regarding this, it asks you to graph it and write down all of the transformations. So all you're going to do is you're going to write down. Oh, and I forgot one. Don't forget, if it's negative out in front, that means it's a reflection. It's going to be flipped upside down across the x-axis. Okay. So those are all the transformations. It's really pretty straightforward. Now, all of the problems that I have on the assignment this week all have a base of 2, okay? And the reason for that is I want you to be able to see a consistent change as far as the transformations. Now, if the base is different, that is not considered a transformation. Okay, if I go from 2 to the x plus 1 to 3 to the x plus 1, that's not a transformation. The graph is going to be different because obviously if I have 2 squared, that's 4. 3 squared is 9. The x is the same, it's still squared, x is still 2, but it changes the graph to be much steeper the higher the base is. Okay, but that does not mean that it is a transformation going from 2 to the x to 3 to the x. It's a completely different function. It's not the same. Okay, that's like saying if I go from x squared to x cubed, that graph is going to be different. Well, obviously, because they're completely different functions. Okay, so when the base changes, that's not considered a transformation. That's just a completely different function. The transformations have to do when I add or subtract to the exponent, add or subtract outside, or multiply by a fraction. Okay, so those are all the transformations that I wanted to remind you of. So let's look at number 1. I'm going to do number 1 for you and with you so that you have this. Number 1 says f of x minus 2. Right? Okay, so the first thing we want to see is, okay, the base of this function, the b, is 2. Okay, so I want to go ahead and graph f of x equals 2 to the x so that you kind of see the basic graph first, and then we can do the transformations to see how that changed it. Okay, so f of x equals 2 to the x raised to the x power. Let's just do a quick graph here. Okay, a quick table. So if I do, let's say -2, -1, 0, 1, and 2 for my x's and my y's. So I'll do a quick little table here. If I plug in 2 to the -2 power, okay, and this is something that we would have talked about in class, but we didn't really have time. Anytime I have a negative exponent, that just means it's going to be a fraction, because 2 to the -2 power is the same as 1 divided by 2 squared. Okay, that's how negative exponents work. It doesn't change the 2. It doesn't make it -4. Okay, negative exponent does not make the whole value negative. It flips the number to the other side of the fraction. Okay, so 2 to the -2 power is actually the same as 1/4. Okay, so when I have 2 to the -2 power, it's 1/4. 2 to the -1 power, same thing. I replace this with 1. That's with 1, and now I have 1/2. So 2 to the -1 power is 1/2. 2 to the 0 power. Anything to the 0 power is always 1. So 0 is 1. 2 to the first power is 2, and 2 squared is 4. So if I graph these points, when x was -2, y was 1/4. We'll do 1, 2, 3, 4. That's all I'll have to do. Okay? So sorry about the glare on there. So I have my point is graphed right there along the x-axis. Okay? When I got 2 to the -1 power, I go to -1 for my x. Y is 1/2. When I do 2 to the 0 power, I got 1. And then 2 squared is, or 2 to the first power, sorry, is 2. And then 2 squared was 4. All right, so this is the way the exponential function is always going to look. It's going to lay down along the x-axis on the left side whenever the base is a whole number. It's going to lay down along here, and then it's going to go up very, very quickly. Okay, so this is the graph of f of x equals 2 to the x. So what is this function doing to that? Well, quite simply, it's just stretching it by 3. It is moving it to the right 1 and down 2. So to graph this function, I take these numbers or this basic graph and I'm going to move it down 2 to the left 1 and then stretch it by 3. Okay, so here's the deal. This number right here, the 0, 1, is the important number. It's called the reference point. It's the number that you'll be able to tell where it should cross every single time. Okay, it's the number that these, just like with the rational function, it was the crosshairs for the two asymptotes. This is the number that will help you graph this all the time. Okay, so basically, instead of being when I graphed 2 to the x, I had 0, 1. I'm going to move it to the right 1. So my reference point is going to be to the right 1. So moving it to the right 1 changes my x to 1. And then moving it down 2. So instead of being, well, first let's multiply it by the 3. So it should be up 3 because it's stretched, because we would multiply the 1 by 3, right? PEMDAS says we got to multiply first. So that would be up 3, and then it goes back down to 1. So my reference point here is going to be 1, 1. Okay, so I'm going to go ahead and graph that. So a similar graph. Okay, so I'm going to graph the point 1, 1. That's going to be my reference point. Now the other difference with this is going to be, where is this part of the line laying? Well, we move the graph down 2, so that means instead of laying across the x-axis, it's going to be down here at -2. So the graph is going to start laying along this, and then it's going to come up this way, and this is the graph of f of x equals 3 times 2 to the x minus 1 minus 2. Okay, it's a very crude graph, which all of our graphs are going to be pretty crude at this point, but that's how you graph the exponential functions. You simply figure out 2 to the x is going to have these points. It's gonna lie across the x-axis, and then once I do that, I can move my transformations. So instead of being right here, I moved it down 2, stretched it by 3, moved it to the right 1, and that's how we got our reference point in for the graph. Okay? If you have any questions, I'm probably going to post something else a little bit later about the exponential rules, because as I was going through that, I realized we hadn't really talked about that in a little bit, and so I want to make sure you understand why negative exponents give you fractions instead of negative numbers and all that kind of stuff. So I will post something about that a little bit later. But this should get you started on the graphing, and I am going to have a Google Hangout, Google Meet on today, Monday, and Wednesday at 2 o'clock, just like I did last week.